This stock photo here, and I got my laser pointer working here. This is a Coconino sandstone. This, like I say, this is not my picture. Coconino sandstone features pretty big in the Grand Canyon. And then you see that white layer across the canyon. Okay, that's Coconino sandstone. And that's 18 miles across there. This is looking from the north rim to the south rim. So tonight I wanted to have a little bit of brief geology. One of the primary reasons that I wanted to go on the Grand Canyon trip was, number one, I wanted to have the opportunity to get the opportunity to present the gospel to ICR guys. And since Dr. Tim Cleary was going on that, and he's, the one that authored the book Carved in Stone, which is a tremendous, tremendous resource. And if anybody wants one, I was given one to give out, so somebody liked that. So he was on that trip. So I was, and I tried to bone up on a lot of geology. Some of you guys have had the opportunity to hear me harangue about geology along the way. In preparation, so I could actually talk his lingo when I got there. And that ended up being actually very important. So that was one of the primary reasons. Second one, I have seen the Grand Canyon from the top several times, but I wanted to see it from the bottom, and I wanted to see what the sediment looked like, okay, and be able to bring back something for you guys. And the third thing was the whitewater. Now, Grand Canyon is one of the premier whitewater rafting events in North America. And for a guy that had never been on an inner tube in the river before, a little bit challenging. So let's do a little bit of geology here first, just to kind of set the stage. Need to talk about a megasequence. A megasequence is, there's 6 of them. A megasequence is basically a layer of sandstone, a layer of shale, and then a layer of limestone, okay? And we're talking hundreds, there's not a megasequence is not just a small little layer of sediment. It can be up to 1,000 or 2,000 feet thick, okay? And there's 6 of them, as I mentioned. The layer of sandstone comes first, and then you got the layer of shale, and then you got the layer of limestone. Now, basically what's happening, as near as the creation geologists can tell, is when the floodgates of the deep opened up, okay? There's 2 things that happen. You're going to get 40 days of rain, and then you get the fountains of the deep opened up. And first thing that happened was on the eastern coast of the U.S., subduction happened. Subduction was when the ocean crust goes underneath the continental crust. And when that happened, that pulled North America east into Europe. And when that banged together, and it closed up an inland sea there, small sea, when it banged together, that produced the Appalachian ridges in the east, and it produced the Caledonian orogeny in northern Europe. See, and then the western subduction happened. Now, when those subductions are happening, they start creating massive tidal waves. And so you get, and this will become a little bit clearer as we go through how massive it is. But when that tidal wave comes in, it just takes all the stuff off the surface of the earth where that tidal wave's hitting it, churns it up, and then it has a chance to settle. And that's why you got the sandstone settling out first. Then you got the clay rocks, which form the shale. And then you have chemical changes, which produce the limestone like that. And so, and like I say, there's six of these mega sequences. The first one's the Sauk. Some of these have eastern U.S. names, and we'll be looking at that in some detail. Then there's a Tippecanoe, and then you got the Kaskaskia. Again, these are all like Indiana, type names. Then the Absaroka, okay? Yeah, we get in there, all right? And then the Zuni, and it's a nice southwest name. Now, those are the 5 layers that were laid down when the floodwaters were still rising. Remember, the rain quit on the 40th day, but the waters rose to the 150th day. So it wasn't to the 150th day that they started coming down. So the first 5 layers of the mega sequences were all laid down in that 150 days. And then when the floodwaters started to drain off, that produced the last one, which is Tejas. And the Tejas is, a lot of stuff was happening. That's when you had the mountain ranges popping up and dropping down. You take the Tetons, down in northwest Wyoming. The top of the Tetons are about 30,000 feet below the base on the east side. That's a 30,000 foot drop. There, 13,700 of it is above sea level, but you got a bunch more of that down below sea level. It's tremendous stuff. The Big Hole Valley's got 14,000 feet of sand and gravel in the bottom of it. See, this is scale that's very difficult for us to process. But the last stages of that were where you get all the modern forms that we see. That's where you get the volcanic action really happening. It's when you get, at Butte, where you get the copper coming up. It's where you get all the tremendous erosion from the floodwaters draining off. It's also where the Ice Age begins. So you have all that happening in the Tejas and immediately following the Tejas. Sequences, there are some mega sequences in the Grand Canyon. You have the Sauk, that's the bottom one. That's the Tepete Sandstone. That's supposedly 525 million years ago. Now what you got to realize is these rock layers don't come with labels on them saying 525 MYA. Okay? The rocks are just there. And so they, the geologists, they put the MYA on there because it looks good. See, I remember taking the kids on a field trip to the Museum of the Rockies, and they used to have a duckbill dinosaur in there, kind of laid even sort of like the stone that was originally in. And so the tour guide lady was taking us through, and she said, now this duckbill dinosaur is about 80 million years old. And I said, well, how do you know that's 80 million years old? She says, well, because of the type of sandstone it's in. And I said, well, how do you know the sandstone is 80 million years old? She says, because it has duckbill dinosaurs in it. Okay? Now, she didn't even connect with her what she's saying, but it doesn't connect with these other guys either. They just built a big circle. And so these are the ages that they put on these things. The Bright Angel Shale, which is right above the Tepete Sandstone on the bottom, that's 515 million years. And then you got the Moab Limestone, which is 505. See, so there's your mega sequence right there. Tepete Sandstone, Bright Angel Shale, and the Moab Limestone. Okay? Now, there isn't any Tippecanoe missing. Then in the Kaskaskia, you get the Redwall Limestone, supposedly 360 million years ago. You can see about a 145 million year gap between the Moab and the Redwall. Okay? And then the Absaroka at the top, and that goes all the way up to that Coconino sandstone that I showed you, and the Kaibab limestone, and something called the Monkopi sitting on the top of that. Okay? So that's your Grand Canyon sediments. Now, all the Grand Canyon sediments are, all the fossils are marine animal fossils. Approximately 6,000 feet of sediment in the deepest spot, and all the fossils are marine fossils, no land fossils at all. Okay. So I was showing this to Katie to start with, just kind of run through it. She says, well, you need to tell them why that's important. Well, okay, probably a good point, Katie, because I try to prove that occasionally I listen to my wife. Okay, but evolution in long periods of time, called deep time, are what's used to debunk the Bible. I was listening. I have a Bible study with a guy, and been going to something called Trinity Church. Trinity Church meets inside the Petra Academy building, and so he said, "I need you to listen to this message by the pastor." And so I did. And the guy's going through, and he says, okay, I don't believe in the 6 days of creation. He said, you're free to, but he said there's too much science against it. And so I went to their website and looked it up, and sure enough, a belief in the literal 6 days of creation is optional. Okay, but I'm just using it as an example how the belief in evolution really does turn people away from the Scripture. I have a tract here. It's from I got it at the Smithsonian Institution a number of years ago, and So it's, I think it's the American Geological Institute, funded by your taxpayers' dollars, okay? The title of this tract is interesting. Why scientists believe in evolution. Believe in evolution. See? You got to remember, evolution is a religious belief that cloaks itself in scientific language. Okay? And so in here, he even uses the Grand Canyon, to illustrate deep time, the 525 million years. So the Grand Canyon is important. The Grand Canyon exposes the most sediment, almost thousands of feet of sediment, in a clearly visible spot. There's other spots that got more sediment, but it's not accessible, it's not visible. Grand Canyon, it's visible, and comparatively speaking, it's accessible. So it's used all the time. And so these sediments are used to justify the long periods of time. That's why I wanted to go. I got to talk about the Kaibab uplift. My job tonight is try to make rocks interesting. Okay. And you guys are a pretty good audience, so far you're hanging with me, okay? I appreciate that. Something called the Kaibab uplift would have caused the Colorado River to flow east. In other words, the Marble Canyon, where we started, is a little over 3,000 feet. At some point, the parts of the North Rim are over 9,000 feet. You got a 6,000-foot uplift there that would have turned the Colorado River, so it would have gone down the Rio Grande course. But see, something happened so that water flowing off the west side of the Colorado Rockies could get through, okay? So what happened was it cracked. Now, we have good examples of that here. If you, like over near Ennis, where I grew up, you've got the Ennis Lake down there in the northeast corner of the valley. Now, the water's flowing out of, by the way, the Madison Valley, I think, has about 10,000 feet of sediment, in case you're wondering. But it should have gone over the low spot on the north side, pretty much where the highway goes over. But doesn't. It goes over way down the northeast corner there in the Bear Trap Canyon. You can see what happened. It cracked. See, and cracks are kind of jaggedy, and you can see the water took that crack, and the water in the Madison Valley dropped down. So these cracks are pretty common. So that's what happened in the Kaibab uplift. Again, you got to remember that sediment was soft, so I'll talk a little bit more about later, but if you go down to the beach and you stick your feet down underneath some sand and you lift your toes up, the sand will crack. Okay, that's what happened here, and so that the Colorado River, the water up above there, had the opportunity to go through that crack and then carve the canyon. And that's why it's wider at the top, and then as the water volume went down, it got smaller. This is a picture of the Kaibab uplift. This is the San Francisco Peaks, Mount Humphreys, 12,700 feet. Flagstaff, Arizona sits right about here, okay? Now, this uplift, see, starts here, goes clear up here like this. Now, you can see in the distance right here, see, it looks like a crack that the Colorado River Canyon goes through the Kaibab uplift. You guys able to see that? Okay? So that helps to understand what you're going to see as we start our journey down that canyon. And the editor should have taken this one out. That's a picture Katie took of me at Marble Canyon. Okay, so, am I comfortable in that? No. Okay. So I got my hat. I said, okay, what do we need? And so they said, well, we got some outfitters. They'll send you everything. We're really experienced on these Grand Canyon trips. So they send me this hat. Okay. Was it the right hat? Oh, yeah. This is the right hat. Okay. Sandals. Yep. Yellow soles at the bottom. That's very important, those yellow soles. And I'm not a sandal wearer, right? I kept my socks on the whole time, though. Okay. And, so here I am. I'm ready to go. Okay. Like I say, I have never done inner tube, much less white water. But for the sake of the gospel of glory of Christ, we'll get her, all right? This is a Google map or Google Earth, that I was able to get off the computer of the Grand Canyon. Now, where I started, just off the map up here at Lee's Ferry, there were only two crossings. There was the Lee's Ferry and just a little upriver, something called Crossing of the Fathers that's underneath Lake Powell right now. That's the only two places you could cross. Canyon itself is about 280 miles long. And I went 180 of it, just off this map here. Okay? In 6 days, 5.5 days, okay? Now you can tell looking at it though, see it looks like a crack, and then the water just right around it ran into it, and there's some, streams coming back, but for this itself right here is the Kaibab uplift right here. So here's your south rim and here's your north rim, the Grand Canyon. So it gives you a little bit of a feel. These are 30-horse motors on the back of these rafts. You had to have the motors because if you just canoe or kayak the Grand Canyon, it's going to take you about 3 weeks. Because like I say, you're going 180 miles. The whole canyon's 270, so that's going to take you a while to get down through it. So the rafts are motorized. This is a schematic of the layers of the sediment. Down in here, there's a certain section of the canyon where it actually carves down through below the sediment into some of the original earth crust, the Zoroaster granite and some of the schist around it. Then right here you have the Tapete sandstone. Again, that's going to feature the Bright Angel Shale, Muav, a little bit of Temple Butte. It's really hard to tell the difference between Temple Butte and Muav. Sometimes the Frenchman Mountain dolomite. And here's the Red Wall. Red Wall is going to feature. And then Supai Formation. Then you have the Coconino, Torowipa, and you got the Kaibab limestone. This is about, at its deepest spot, about 5,000 feet of sediment here. Deepest part of the canyon is 6,000 feet deep. Just to give you a perspective on that. See, so it's quite a. Now this is these are our rafts, okay? 2 of them. Like I say, they're 30 horse power running these things. Everything we need on the raft is, for the week is going to be on there. So they got us on there, and they said, okay, this is a whitewater rafting trip. Okay, some of the roughest rapids there are in North America. Now, they said the only place you can urinate is in the river. So, ladies upstream, men downstream. Okay? We have other facilities for you we'll take along the way. And they said, look, once we push back, the only way you're getting out of here is by helicopter. And the only reason we call a helicopter is in case of serious injury. So, if you don't think you want to go on this, now's the time to get off. Nobody will say anything. You just get off quietly and make your exit. And because once we pull off of here, you're going to get out of here at the end or by helicopter in case of serious injury. Okay. And they said, here's another thing. You're all required to wear life jackets. Primary reason for life jackets is so we have something to grab a hold of when you get knocked off. Okay? So they said, are you guys all in? See? And then you had to nod that you're all in. See? Okay. So I'm sitting way over here on this edge of this raft. Okay? Now, these cables right here are ropes. If you want to do the whitewater experience, you get down there, right? And you got one hand like this on the one in front, and you got one hand like this in the back because you're going to get thrown both ways. You got to have 2 hands going through those. And they said, look, you guys down in front, when we say duck, we mean duck. That means suck rubber. Those are rubber rafts that they made, right? And so I get on the raft and I'm looking. I'm 75 years old, and I said, I can see that is not going to work. Okay. And then they have the princess section back behind these boxes here, but you got to have your legs straight out in front of you to do that. And well, that's not going to work either. So I'm going to sit on one of these boxes of supplies here. That's where I'm going to sit. Now they told us, they said, no, look, you guys move around. Don't be like Aunt Joyce. Just, kind of trade off a little bit. And I said, I'm Aunt Joyce. Okay. Staying right here. Okay. And so we pushed off, and we're ready to go. And of course, this is a quote Christian group. So after they get down the river just a little bit, they pull off, and you introduce yourself and you give your testimony. So I gave my testimony of atheist to preacher and disciple maker, right? And okay, so all good. Headed downriver. This is the Vermilion Cliffs here. This is at Lee's Ferry, just where we take off. They're not, for the most part, sediments that appear in the Grand Canyon, except right at the first, okay? Now, here's a schematic, just to try to, again, give you a picture here. Why I wanted to see this from the bottom. Here's the Grand Canyon itself. There's your sediments there, 5,000 to 6,000 feet of sediments. Then you can see this here goes underneath. Okay, there's a set of lower cliffs here that you could have seen if you could have seen it. Then here's your Vermilion Cliffs, then your White Cliffs, the Gray Cliffs, Zion Canyon, and then way up here Bryce Canyon in the mountains in Utah. Okay, so you got 5,000 feet of sediment here. You got another 10,000 feet of sediment sitting on top of that. So you got 15,000 feet of sediment right here for the viewing. Okay, so how are you going to get that much sediment, okay, is always a really, really good question. We'll kind of explore that. So, and here's a picture. Okay, I knew I was going to be making this presentation to you guys. I had it in my mind. And I wanted to get a picture of the grand staircase. See, we're just looking at the Vermilion Cliffs, the Gray Cliffs, the White Cliffs, clear up to Bryce Canyon. This is it. So we're headed up the Kaibab uplift, and I said, Katie, we're stopping the car here. So I stop and get out, get my camera. There's your Vermilion Cliffs. There's your White Cliffs. And there's way up where Bryce Canyon is, about 11,000 feet elevation. You're looking 70, 80 miles across there. But that gives you an idea how that sediment is stacked there. And again, it's deep. You have to try to process how deep this is in order to get a picture of what the flood was really like. So any quick questions here? Okay. So we're starting off here at Lee's Ferry. Here's the Navajo bridges. Okay, Navajo bridges are 475 feet above the river, just to give you a little perspective. Okay, half the Empire State Building. Now, right here, the Coconino sandstone just coming in, Kaibab limestone has just started to show up, okay? These sediments are just beginning right here, okay, as we're starting our way through. You can see the other raft way down there, up ahead. I was in the second raft. So we're going along. We're about 10 miles in, okay? There's that Coconino sandstone way up there. This is the Esplanade sandstone. It's near the top, but right here it's at the bottom of the canyon. See, as you start to work your way through it. So it wasn't very long, and we hit our first rapid. See, the Colorado River in the Grand Canyon is a really great river because it educates you in stages. Okay, and so there are some young guys up front, 17 and 18 years old. They want a whitewater, boy. We want to do this whitewater. So we come up to the first rapid, which is only a 5 or 6. Grand Canyon has its own rating system on the whitewater. And so 10 out of 10 is the highest. And there's some of those that we hit. The first one we hit was about a 6. Okay, and so we're coming up. I'm sitting on this box, and I got my hand gripped right here. There's a strap underneath me, and I've got a strap that I'm reaching back for, okay? And so we're coming up, and that wave got bigger and bigger. So, whoa, this is going to be something, see? And then we hit her. She rocked us pretty good. And I said, okay, that's a 5 or a 6? Okay. Yeah, I'm starting to realize, yes, that this is serious. And but that was the beginning, okay? The education continued. I'll tell you. Glad you brought it up, though. So this is sandstone here, and you notice these layers here. This is called cross bedding. Now, when you got a sand dune that's forming, okay, there'll always be these cross beds. You have your flat, and then the dune itself will have the angles on it. Now, sandstone that forms in the open air, like the dunes, say, along the Oregon coast or something like that, they call that aeolian. You always got to have aeolian, right? That's so you don't know what they're talking about, and I do, type of thing. See, but aeolian cross bedding is always something like 30 to 37 degrees. Underwater dunes form, and underwater dunes are something like 20 to 25 degrees. All the sandstones show cross bedding, and all the sandstones show cross bedding at 20 to 25 degrees. Now, if you get their literature, their literature is going to say those were dunes formed in an ancient desert. They're all underwater dunes, all of them. I don't think they could really want to say that, would they? But that's just one example of those dunes. You see them all the way through. This is called Redwall. We're up to the Redwall. We're about 25 miles into the canyon here. This is called the Redwall limestone. And Redwall is kind of a gray-colored limestone, but the rocks over the top of it have a lot of iron that leaches down and makes it red color. So that's why it's got the name Redwall. This is Redwall Cavern. Now you can see, here's the other boat. And so you can see the sand in the bottom of that cave, maybe 10 to 12 feet deep. Okay? That's what that cave looks like on the inside. Now, I know I'm a preacher, but I figured you could put 1,000 chairs in there. 1,000 chairs, preacher's count, okay? And that's a lot of sand. So I'm standing there and I'm looking down at my sandals and looking at all that sand. It took a lot of rock to get pulverized upstream to get that much sand, 10 to 12 feet deposited in that cave. Then my mind took another leap. Okay, we were just looking at that Esplanade sandstone, right? Esplanade sandstone is thick, runs the whole length of the canyon. It's near the top, or about 1/3 of the way down. All that rock had to be pulverized first before it could be turned into that much sandstone. See, that starts helping you process a little bit the size of those tsunamis coming in. Because they come in first, they hit the lower levels first, and then after a while the next layer comes in. So your first mega sequence is going to form first, then your next mega sequence, then your next mega sequence. Eventually you're going to get to the dinosaurs, but that's near the top. Oh, and mammals and man. Okay? But all that rock has to be pulverized, turned into sand and into shale, or into clay, and settle before it can turn into rock. All right? Big. Further down the canyon, this is called the Muav, okay? And sometimes there's something called the Temple Butte Formation, sometimes Frenchman Dolomite. There's spots in the canyon you can't tell the difference. So basically there's a line right here between the Muav and the Redwall. It kind of goes around the corner so you can't see it. The Muav limestone is not quite as strong as the Redwall, so it tends to collapse a little bit. And so that's why you've got these collapsible layers here. And then the Redwall is pretty pretty solid, so those walls tend to be pretty vertical. Now, they claim that the canyon is 9 million years old. I mean, they've lowered it quite a bit in recent years. I mean, it's getting younger as they go along. But look at it. Look at these rocks right here. See, this steep wall, so that stuff's going to keep eroding, isn't it? And so you're going to have chunks like that all the time, and you can see this stuff sloughing off here. Okay? So let's use a little uniformitarian analysis here. Let's say that the canyon is eroding at the rate of 1 millimeter a year. Okay? So you guys have seen the rulers, right? In the millimeter, that's the littlest, tiniest mark on there. Takes 10 of those to make a centimeter, right? Let's say it's just eroding at an average of 1 millimeter a year. Okay? So in 1,000 years, that'd be a meter, roughly 3 feet. Okay? In 10,000 years, that'd be 30 feet. 100,000 years, that'd be 300 feet. 1,000,000 years, that'd be 3,000 feet. See, but long before you hit the 9 million years, the canyon will be gone. It's not that old. It's not that old. So there's a line right here, is about 140 million year gap. Okay, so it's a straight line. For the most part, all the way through the canyon, all these layers, straight line, straight line, straight line. 270 miles, straight line between sediments. So, you ever had say a gravel driveway and a little bit of an angle to it, and a thunderstorm came through? What happened to your gravel driveway? Okay, got a canyon right through it, right? Ever happened to anybody, right? Okay, that's what happens in erosion. See, if those were millions of years between those layers, there should be lots of erosion, but there isn't any. Flat lines. See, no gap. No. So I was standing there talking to Dr. Cleary about it, and he said, the fact that right there between the red wall and the Muov, that there's really no gap there, it's supposed to be 140 million years, really no erosion, he said that's their signal that their paradigm is wrong. I said, yep. Okay, lodge that away. Oh, what do you know? Welcome home. Okay, so here's your bridgers. Now this Ross Peak here, and Ross Peak's limestone. In fact, it's Madison limestone, and you can tell what happened is there's a tremendous gap between here and here. What happened is when the bridgers were lifting up, what became Ross Peak, it snapped. The limestone snapped right there. Boom, part of it like that, just like breaking a piece of licorice or something. Think of the force that it took to do that. So this is Madison limestone. You're going through the pass between here and Livingston, that big old white rock on both sides, but the one that really stands out is on the south side, Madison limestone. Same limestone. That is the same as Redwall limestone. That's the same as this. Okay. Now, it doesn't take much of a calculation to say, it's quite a ways from northern Arizona to southern Montana, right? There's places in Montana where the Madison limestone is 1,700 feet thick. Does that sound like a small inland sea formation? We're talking hundreds of thousands of square miles of Redwall / Madison limestone. Hundreds of thousands of square miles thick. See, that has to be catastrophic. Anybody that objectively look at it, catastrophic. Any questions here? Pardon me? Yes, it is. Yep. Nick? because it is. It's the same composition and everything. You know, underneath that, see, Madison limestone has that kind of distinctive sort of almost blue-gray color just a little bit, you know, with the certain types of fossils in it. That's exactly what the red wall is. It just is a little bit colored because of the iron over the top. It's the same. And if you were even to Google that, and the secular geologists, they're going to tell you, yep, the Madison limestone's the same as the red wall. Because it is. See, the geologists know what's there. They really do. They just know how it got there. Anything else? Yeah. Okay, well, ever spend any time, you know, scraping the hard water stuff off your fixtures? Yeah. Okay, that's calcium carbonate. That's the same as limestone. It acts just like limestone, okay? Okay, all water's got a lot of calcium in it, okay? Now, all water will also have a certain amount of dissolved carbon dioxide in it. And so if that has an opportunity to precipitate out, it'll form limestone. For example, at Bermuda, there's a shelf there where the calcium carbonate periodically dissolves and then it really forms again. So just because of certain changes, chemical changes. A big thing that would cause limestone to form would be a change in atmospheric pressure. See, when you pop the top on your pop can, you know, some people call it soda, but, you know, ignorance abounds. But when you pop the top on your pop can, I mean, it's called pop because it goes pop, right? But what happens, you change the pressure. And that carbon dioxide was all dissolved in your drink, and when you released the pressure, that came out. When you change the pressure and you got carbon dioxide dissolved and you got calcium, see, it'll instantly form a floc, F-L-O-C, chemically. You could do that in a beaker or something at home. This just happens to be that stuff forming on a massive scale. So you had the sand coming in, settle on the bottom. You had the clay settle down to eventually form slate, and then the chemical change that happened in connection to the flood, you had the limestone. See, and that's why your limestone, if you go to Lewis and Clark Caverns, guess what limestone it is? Madison. All kinds of fossils, right? And they're all marine fossils. See, and that's why. Anything else? Well, we didn't talk about that because he already knows that. He actually did his doctorate work I found this out Indiana University has a geologic station in South Boulder River in the Tobacco-Ritz, because these same sediments are actually exposed there along 7 or 8 miles of the South Boulder River. So he actually did his doctorate work there, so he was familiar with the area. Yeah, good. All right, this is where the Little Colorado River comes in to the main Colorado. It's kind of turquoise because there's a spring upstream there. Now, some of you guys remember when we did that geology presentation, we showed the Mount St. Helens on the university campus, and Dr. Feely was rude and obnoxious, so much so the students apologized. Well, in the midst of that, you remember one of the students asked me, he said, "Do you have any evidence for the rapid deposition of sediment there?" And I said, "I do." Little Colorado River is a meandering stream that comes into the main Colorado. But its walls are straight down vertical, up to 2,000, 3,000 feet deep, okay? But it holds the meander for the entire length of those, the canyon. Now, the only way you can get vertical walls like that is if the sediment's all soft. See, which gives you a picture of what the sediment was when it was forming here before the Colorado River tore through it. Okay, so it was soft because you can tell what happened. Here's that crack happened. All the water connected with the main Colorado went right down through that. Now all of a sudden, here's the Little Colorado up here. So what's it going to try to do? Well, it's going to try to get down to the same level as the main Colorado. So it's going to chew down. But see, if the rock is soft, it can chew straight down. And that's what it did. So that's really strong evidence that the sediment was all soft. Okay, and the kid, he picked up on it. Dr. Cleary didn't hear anything. Dr. Feely didn't hear anything, but he picked up on it. Because again, it's there. Like Dr. Cleary says, the rocks don't lie. They're there and they're talking. For anybody pay attention to them. Across the river is this. This is 3,760 feet from the base to the top. That's right across where the Little Colorado. All the sediment is exposed. Right down here is the Tapeats limestone. You got the Muav, you got the Red Wall. Up here you got the Supai Formation. You can't see the Hermit. Then you got the Coconino limestone, and then you got the Kaibab up on top. It's all right there. Look at those lines. Straight line, straight line, straight line, straight line to the whole canyon. But that gives you a picture, like I say, to realize that this is roughly equivalent, let's say, from here to the top of the Bridgers. It gives you a little bit better perspective of what that's like. So it's a little bit less than, but right from here to the Saddle Peak Pass, or Ross Peak Saddle, that'd be about what it is, almost 4,000 feet. It kind of dwarfs you. And so this is up on top. This is a tower that was built in 1927 so people could view the canyon from the South Rim. How many of you have been to that tower, where that tower is? Yeah. Okay. Pretty cool. Okay. So here's what it looks like from down below. It's right there. Okay? So, you can see why I wanted to see it from what it looked like down below, right? And here's a picture from up above, and right about here is where that other picture was taken. See, pretty interesting. Oh, and there was some wildlife there, and along the river, not much. One night, a buck deer came wandering into our camp, and wandered out. We had we had cots, that we put up, to sit on or sleep on, and if you wanted a tent, you could have one. One night it kind of rained, but I had rain gear. Okay, now one of the things they told us, they said, look, you should have rain gear. I mean a heavy rain jacket and rain pants, because the river is 50 degrees, and you're in the desert, but you're going to get cold. And they said, we'd rather have you have an enjoyable trip rather than a miserable trip. So the second day, I donned my rain gear. The second day, we started hitting some rapids, okay? And so the boys are up front, bring the rapids on, bring the rapids on. The next one we hit was an 8. Boom! Hit that thing. One of the guys lost his left shoe. Okay? Next rapid, the other young guy, he lost his left shoe. Because that thing is knocking you around pretty good, see? And both those when the one young fellow lost his left shoe, he's back in the Princess section for the rest of the trip. He's done. Okay? The other young fellow, he tried it for another day. He's back in the Princess section. Because it does hit you pretty hard. Those waves do hit. There's one spot going through, and it was only an 8. But I got hit so hard with the wave that I got knocked clear back into the Princess section. I just, this hand that was behind me is out in front like this. I mean, it's one thing to ride a horse that's bucking a little bit. It's another thing to have a wave hitting you while the bucking's going on. So they, and it just depends. See, you got the standing waves of the rapids, but you also have other waves inside the standing waves. See, it depends on how those hit, so you can get hammered pretty good. So I'll be honest, I got hammered pretty good on this trip. Okay. I thought this was a picture to give you just an idea of what it's like waking up in a beautiful morning. You've camped, on these cots, and which is a little rough on the 75-year-old back, and got up, and Man, this is just beautiful. That cloud there is below the rim level. So you can see all the layers of sediment. Here's the Coconino sandstone. That's the Kaibab limestone. Just, just the way it was. Most of the nights were clear, and the meteor shower was going on overnight as well. So, to the extent that I could stay awake, I got to watch the meteor showers. Appreciate those guides. Those guides were up at 5 o'clock in the morning getting breakfast ready. Now, each guest paid $4,000. There were 24 guests, 12 on each raft. And somebody heard me talking about it, and somebody sent me a check for $4,000. Or I'd have never gone. Okay, but now I'm hung. Okay, I gotta go. So these guys are up. They fix breakfast. They do a great job. Fix breakfast. And pack. Get everything packed up, and then you have a set up for a fairly nice lunch, and then supper time. They, the last evening they cooked steak. I mean, it was, Now they had to haul all that stuff in. So those guys worked. I mean, plus they're trying to run the river in the daytime. I talked to the guy that was driving my raft, and because I said, even in the calm spots, it looks rough to me. He said, yeah, because that river is boiling. And he said, on the Colorado, if you lose your concentration for a minute, the river's going to get you. There have been quite a few people died trying to run the Colorado. Okay. And the river, at its widest spot, 750 feet wide. Its narrowest spot is 76 feet wide. There's spots where it's 100 feet deep. See, so that's hitting underneath rocks and everything, just churning and boiling all the time. And so these guys, they have to earn their money. So there's one guy on the motor, and the other guy, he'd usually strap himself right next to me, but he's standing up. So we hit one of those rapids, and one of those young guys broke loose. This guy grabbed him so fast. And it's a good thing. Because they told you, rule number one, if you get knocked off the boat, rule number one, get back on. Okay? If you have to float downstream, float downstream. The boats can't go upstream. See, the Colorado is one of the rivers that, a lot of the whitewater rivers, they can still run the boats upstream. There's only been two jet boats that have been able to make it up the Colorado. See, so if you get off, you just float downstream, and we'll try to find a soft spot and pick you up. See, so rule number one, stay on the boat. Okay. These guys, they did a great job. I tip my hat to them. This is here's a good spot. This is the Tapete Sandstone, and I want to focus a little bit on that. You can see the other layers here. We're quite a ways down the canyon by this point. We're about the 150, 160 mile mark, and same sediments. It's interesting to me, the little bit less color the further west you go in the canyon. Okay. Now here is a side canyon. This is called Blacktail Creek. Now you'll notice right here, this is a granite base. That's the original Earth's crust. Okay. Then you'll notice a line right here, kind of some quartz-like stuff. Okay, and then above it you got the Tapete Sandstone. Okay. Now this line right here, where these two different rock types meet, when you have two different rocks meet, that's called an unconformity. This is the great unconformity. The great unconformity is where your first layer of sediment came down and contacted the original Earth's granite. That's significant to us because this is the first place, see, when those big tidal waves came in and planed off the original Earth's surface, then this is where the first sediment was piled in. It was right here. Oh. This is east of Melrose, just off of I-15 between Butte and Dillon. Where the sagebrush is, that's your original Earth's surface granite. It's kind of been metamorphosized into mica schist. And then right up here, this layer is called Flathead sandstone. It's named for Flathead Pass, where they first discovered the sandstone. And this line right here is the Great Unconformity. See, I had to look hard to find it, but I finally found it and tracked it down. So, right here, this is rock that sits on our back porch as a good backdrop for flowers. Okay, or this is a Katy collection, is what this is. Okay. Now, that's the same as this stuff right here. See, it's that kind of a brecciated sandstone, a lot of quartz in it. That's the first stuff that settled down. Okay. Then above that, here's some of the sandstone. This is, the regular Tapete sandstone. It's the same as, this is Flathead sandstone, but it's the same as Tapete. I was reading about this guy. The secular stuff, they know that. There's this guy, he was going along the Flaming Gorge Reservoir between Colorado and Utah. And the sandstone there is called Lodore, L-O-D-O-R-E. And this guy had worked 40 years in the Grand Canyon. He said, hey, that's Tapete sandstone. So you can tell what it is. So this is your Flathead sandstone. Same sandstone is in the bottom of the Grand Canyon. A little ways away from Arizona. And this sandstone goes all the way to Lake Michigan. Hundreds of thousands of square miles. Okay? Trying to give you a little bit better picture here. There's the vehicle here. There's your layer of sandstone. Now, right above it is a layer of shale. Now, in the Grand Canyon, you've got the Tapete sandstone, and then you have the Bright Angel shale. Here, you got the Flathead sandstone, and then you got Woolsey shale. In the Grand Canyon, you have Muav limestone. Right here, you have MAR, M-E-A-G-H-E-R limestone, right here. So, I didn't get any limestone, but I have some Woolsey shale. And if a person were to dig enough and pry open enough of these, they'd find trilobite fossils right there at just outside of Millstone. This is this is the schist. This is the granite that's metamorphosized where the sagebrush is. Same stuff as in the basin of the Grand Canyon. Same stuff. The Great Unconformity is worldwide. Just had this picture taken. Gives you an idea how big that little crack was, that you were looking at earlier. It doesn't look that impressive. And I make it look more impressive. These are lava flows. This is about mile marker about 170. You can see the little volcano up there. As the flood is coming to a close, then you had the final stages of volcanic activity. Now, all along the west coast, you had that subduction happening. The subduction then is pulling that the Pacific Ocean floor down underneath. It's hitting the magma, it's shooting up and causing the volcanic. Okay, now that subduction happened on such a scale that was pulling the North American continent west at the rate of 50 feet per second. And formed the whole Atlantic Ocean. Okay? And they know that because there's chunks of the original Pacific Ocean floor down underneath. Big chunks. And but it's cooler. It's cooler than the magma around. In other words, it hasn't been there long enough for heat to equalize. Just incredible what was going on in the flood. Okay? Now, at the tail end of that then, you had these massive basalt flows. You take Mount St. Helens. Mount St. Helens is a granite-based volcano, so it tends to be very explosive. Okay. Now the Hawaiian Islands are a basalt, the black rock, type of volcanoes, that tends to flow. So that's what you had here, is you had these flows here, and they happened just about the time, or just before the Ice Age. Okay, so they know that the canyon was in existence before the Ice Age, right? Which is helpful. The Ice Age, how did that happen? Okay, you got a warm Pacific Ocean floor. You got that magma. Okay, number one, what caused the waters to flow up? Well, you had that magma forming in the Pacific Ocean. Magma is warm, right? Occupies more volume, so the water level's up. Okay, how are you going to get the water level to go down? You know, there isn't a drain plug over in the corner, lift her up in the floodwaters. So that magma starts to cool. See, that's what starts pulling all the water off the land. At the same time, with that warm Pacific Ocean floor, that's going to cause a lot of evaporation. A lot of evaporation means lots of precipitation. But all those volcanoes going off means a really cold atmosphere. So the combination of a cold atmosphere and lots of precipitation, guess what? Snow. Glaciers. Okay. All these mountain ranges here, if you take a look at them, the south and the west side is pretty smooth. See, the north and the east side is really glaciated. See, because that's where the glaciers were forming the thickness, as you would expect. And so these originally, like you take the Tobacco Roots on the west, that was just a nice dome. That was just a nice lava dome pushed up. And then the glaciers were so strong to carve all those canyons and all those peaks into the shapes that they are now. So again, this is a scale very difficult for us to process, but that's what's happening. The ice at some point was about 15,000 feet thick in Canada. Came down almost as far as Great Falls in the state of Montana. And the Ice Age caused a tremendous ice dam on the Clark Fork River, down around Thompson Falls. Dammed up, it made a lake as big as almost as much as half of Lake Michigan water. When that broke loose, that caused all the scablands around Spokane, Washington. See, this stuff is happening on a scale here, that last mega sequence, you got all this stuff happening. So this here, the lava here, is a result of some cracks in the earth. Basalt comes from the ocean floor. So how many have been to Palisade Falls? Okay, Palisade Falls is there because it's flowing over a basalt sill. That's basalt. Okay, that's a long ways from the ocean, isn't it? But see, that gives you an idea of some of these tremendous forces. You had the whole Columbia Basin is basalt. See, that's because there was it was coming up from the ocean floor and spreading out. The original boundary of North America is approximately the boundary between Montana and western Idaho, eastern Idaho. All that formed west of that was a result of these subduction and explosion processes in connection with, especially the last stages of the flood. Just huge. I think you could say God was angry. That's what I think you could say. Well, the flood points to salvation through Jesus Christ. So, that's what Dr. Clary said. And he said, yep, he turned to Ephesians 2:8 and 9 and said, yep, just a little faith is all you need. So I sent Dr. Clary an email, and I said, really nice, spend some time with you, thank you, and so forth. I was able to do some things to make some personal connection. I said, but you remember when we were looking at where the Muav and the Red Wall were? And you said the fact that there's no erosion gap between the Muav and Red Wall, I said that's their signal that their paradigm is wrong. I said there is a scripture that makes the connection between salvation and Jesus Christ and the flood. It's right here. Those who perished in the flood, once the disobedient, when the patience of God kept waiting in the days of Noah during the construction of the ark, in which a few, that is 8 souls, 8 persons, were brought safely through the water. Corresponding to that, immersion now saves you. Not the removal of dirt from the flesh, but an appeal to God for a good conscience through the resurrection of Christ. I said to Dr. Clary, that's your signal that your paradigm's wrong. He basically said, thanks for the letter and email, and he said, I just didn't explain it well enough, and have a good day, brother. But I made my shot, okay? I got, I got a couple other possibilities here that I'm going to continue to follow up on. Okay, now how do I get out of here? End show. Okay, that'll do it. Maybe. I didn't get it. That's the trouble with a strange computer. This is not a Mac. Okay, I just clicked it wrong.
Are you done?
I'm done with that, yeah. So let's do a little whitewater.
Actually, there might be one.
I'm going to try to back this up just a hair. There's something I want you to see. I told you to remember those yellow sandals. Okay. There they are. So let's get out of here. Gives you a little perspective how big the canyon is, right?